We have 1 plus cosine x on the spot. The first one, the integral 1 over 1 plus cosine x, and we see that the 1 plus cosine x is in the denominator. And for the second one, we have the integral, and the 1 plus cosine x is in the square root. So which one would you guys like to do first? Okay, the way we are going to approach these two integrals are the same. So let me begin with this one. And especially if you guys are taking Cal 2, you should definitely know how to work out these kind of integrals, especially with this kind of approach. Here we have the integral 1 over 1 plus cosine x. This is no good. I wish we can just have a sine x on the top because that would be so much easier, right? However, that's not the situation. So let's see. You have to keep in mind when we have a rather complicated integral, but then if you just have cosine, this is no good because we also want to have sine x because sine and cosine, they help each other out in the integration, right? So what can we do? Let's focus on this one right here. We have the 1 plus cosine x. We don't know that too well, right? But there's an identity that we can use. I'm going to write it down right here, keep it on the board. We know that when we have 1 minus cosine to the second power x, if this is what we have, we know we can change this to sine square x. And we have been using this in the past many times, right? Especially when you are doing trig sub, things like that. Well, what's the connection between 1 plus cosine x and 1 minus cosine square x? Notice that this is secretly a difference of perfect squares. 1 square minus cosine square x. With that being said, we can actually factor this out. Once we factor this out, we will get 1 plus cosine x, and then we multiply with 1 minus cosine x, right? So you see, here we already have 1 plus cosine x. What if we multiply the bottom and the top by 1 minus cosine x? In that case, the denominator will become sine square x, and then hopefully everything will go smoothly from there. So let's do that. We already have this, so let's multiply the bottom by 1 minus cosine x, and then do the same on the top. Okay, and I'm just going to leave this on the board. Alright, so let's continue. This is the integral. On the top, 1 times 1 is just 1. 1 times cosine x, of course, is just a minus the cosine x. On the bottom, this times that, which is this times that, which is this, which is going to be sine square x. Let me just put that down right here for you guys. And then, of course, don't forget the dx. And now we see the advantage is that we only have one thing in the denominator, so we can split this fraction, right? So we can look at this as the integral of 1 over sine square x, and then minus cosine x over sine square x, right? And you can put parentheses if you like, but it doesn't really matter that much. Anyways, how can we integrate 1 over sine square x? Well, let's change that. What's 1 over sine? It's cosecant. What's 1 over sine square? It's cosecant square. So this is the same as saying, let's integrate cosecant square x, okay? And then how about this? If you just look at this as an integral by itself, cosine x over sine square x, then you can do u sub if you would like. However, I'm just going to break this down for you guys. I can look at this as, let me put this in red, 1 times cosine x, and then I can look at sine square x as sine x times sine x, right? For the first pairing, 1 over sine x, that's cosecant x. I'll put this down in red, cosecant x. And we still have that subtraction. And then you see we have cosine x divided by sine x. That's cotangent. So we can multiply by cotangent x. And the purpose of doing so is because if we know our derivative table really well, then we can integrate this, we can also integrate that. So let's get to work. Derivative of what will give us exactly cosecant square x? The answer to that is negative cotangent x. Okay, let's review this real quick. The derivative of cotangent x is in fact negative cosecant square. but then this was positive, so we must have this negative, so the negative times negative will give us the positive version of the cosecant square. So be sure you have this negative right here. And now, derivative of what? And that's include this negative. Derivative of what will give us exactly negative cosecant x times cotangent x. The answer for that is just the regular cosecant x. So that means it's a positive, okay? We add it with cosecant x. If you differentiate positive cosecant x, we get exactly negative cosecant x times cotangent x. We have to know our derivative table really well. And don't forget to be sure the sign works out correctly. And we are done. So we can just put plus c and move on to the next one. Alright, let's look at this one. We have the integral of square root of 1 plus cosine x. Well, same situation, right? This is really complicated, and then unfortunately I just have a cosine x in the integral, so that's no good. Why don't we try the same strategy here? We have 1 plus cosine x already in the square root. Why don't we multiply and divide by this 1 minus cosine x? So let's do that. So this right here is in the square root. Everything should still be in the square root. We multiply this by 1 minus cosine x, and then we also divide it right away, 1 minus cosine x, okay? So what we're going to get is the integral, and we have the big square root. This times that is that, 1 minus cosine square x, which is the same as sine square x. So that's the numerator. Let's just put that down here. And then over, this is still inside of the square root, right? Because I multiply this in the square root, I also want to divide the same thing in the square root. So I should have changed this, make it bigger to make this clear. This is in the square root as well, 1 minus cosine x, and then we still have that dx. Okay, this is the integral. What I want to do is, I just want to take the square root of the sine square, because that way, squares will cancel. So on the top, I will just have the regular sine to the first power x. Without putting down the absolute value, we don't worry about the absolute value when we're integrating, okay? And then over square root of that, okay? The denominator just stays how it is. 1 minus cosine x in the square root in the denominator, and then we still have this dx. And now what? Well, right here, we can just do u sub. Let's say u equals to 1 minus cosine x, and then we get du, which is going to be, this right here is positive sine x dx, and then divide both sides by sine x, we get dx equals to du over positive sine x. And now what? We take this integral into the u world. I will just do it right here. This is the integral. Sine x stays the same if you like. I want to show you guys the cancellation. This is the square root, and then we have the u, right? And then the dx is that. We have the du over positive sine x. This, that cancel. Very nice. And we just have to now integrate 1 over square root. What do we do with that? This means u to the negative 1/2 power. U to the negative 1/2 power. That's 1 over square root of u. And then we have du. We can just get to work right here. Let's add 1. Negative 1/2 plus 1 is positive 1/2, and then divided by this new exponent. Divided by 1/2 is the same as multiplying by 2 over 1. So, pretty much we have just a 2. And then square root of u, right? If you like, let me put down u to the 1/2 power for now. We're done. But then, the usual business. Let's write the 2 as 2. Let's write the 1/2 as a square root. Let's write the u as that. 1 minus cosine x. And then we're so done. Put plus c. That's it.